Welcome to Gartex channel. In this tutorial, we will learn about operational amplifiers in general, their characteristics, their applications and some of the important operational amplifier basics. If it is your first time hearing about operational amplifiers, I'm sure you are wondering what is an operational amplifier. Electronics may be difficult to understand sometimes, but in this tutorial I will try to make it as simple as possible for us to understand key points about operational amplifiers. An operational amplifier is one of the most frequently and widely used electronic component in electronics. They are the main building blocks in analog circuits and are used in a wide range of consumer electronics, industrial equipment and scientific devices such as AC and DC signal amplification, filters, oscillators, voltage regulators, comparators, and in most of the consumer and industrial devices. An operational amplifier is a high-gain voltage amplifier that is designed to amplify electrical signals without introducing unnecessary noise or distortion. The word amplify simply means to increase the strength of an electric signal or to make something, such as a musical instrument, louder by increasing the strength of electric signals. So what is an operational amplifier? An operational amplifier is defined as a high-gain voltage amplifier that is designed to amplify electrical signals without introducing unnecessary noise or distortion. From our definition, note that we have said that an operational amplifier is simply a high-gain amplifier. The operational amplifier is called so because it has its origins in analog computers and was mainly used to perform mathematical operations. The device consists of a differential input stage, an amplification stage, and an output stage. The device can be operated in a variety of configurations to achieve different functions, including voltage amplification, filtering, and waveform generation. Much like any other amplifier, operational amplifiers offer gain, bandwidth, and noise characteristics to allow them to be used in a variety of applications. However, their unique qualities come from the wide range of parameters available to customize their performance. Let us now discuss the main characteristics and parameters of operational amplifiers. Key components of an operational amplifier. The most common operational amplifier is the integrated circuit chip, which contains many other components on a tiny silicon wafer. These components include transistors, resistors, capacitors, and diodes. The differential input stage is typically composed of two input transistors and a current source transistor. The amplification stage employs voltage amplifiers, and the output stage may include current sources, buffers, and other circuits as needed. The input stage of an operational amplifier is designed to provide a high input impedance, which allows the device to be used with a wide range of input sources. The amplification stage provides the high gain required for many applications, and the output stage is designed to provide a low output impedance, which allows the device to drive a wide range of loads. Now that we have understood what is an operational amplifier, let us discuss how an operational amplifier works. The operational amplifier operates by amplifying the difference between the two input voltages. The amplified output voltage is determined by the gain of the amplification stage. It should be noted that operational amplifiers have a very high gain, in the range of 10,000 to 100,000 or more. This gain is controlled by an external feedback resistor or network of resistors and capacitors. The feedback network is used to control the gain and performance of the operational amplifier. By adjusting the values of the resistors and capacitors in the feedback network, the frequency response and other characteristics of the amplifier can be tailored to meet specific application requirements. The output voltage of the operational amplifiers is influenced by the input voltages, the gain of the amplification stage, and the feedback network. By adjusting these parameters, the operational amplifier can perform a wide range of functions, including voltage amplification, filtering, and waveform generation. Operational amplifiers can be used in a variety of configurations, including inverting, non-inverting, differential, and instrumentation amplifier configurations. Each configuration has its own advantages and disadvantages, and the choice of configuration depends on the specific application requirements. What are the basic types of operational amplifiers? 1. Inverting operational amplifiers. 2. Non-inverting operational amplifiers. 3. Differential operational amplifiers. 4. Voltage follower operational amplifiers. These are some common applications of operational amplifiers. The most common application of operational amplifiers is signal amplification. By adjusting the gain of the amplifier, small signals can be amplified to levels that are measurable by instruments or other electronic circuits. This is particularly useful in audio amplifiers, where weak signals from microphones or musical instruments need to be amplified to produce audible sound. Operational amplifiers are also used in medical equipment, such as electrocardiograms and blood pressure monitors, to amplify biological signals. Operational amplifiers are also used in active filter circuits, where the gain and frequency response of the circuit can be easily controlled by adjusting the feedback network. These filters are particularly useful for removing unwanted noise or signal components from a signal. Active filters are used in audio equipment, such as equalizers and crossovers, to separate and amplify specific frequency bands. Operational amplifiers can be used to generate oscillator circuits that produce sinusoidal or other types of waveforms. These circuits are useful for generating timing signals or for creating test signals for other electronic circuits. Oscillators are used in clocks, radios, and other electronic devices that require a precise timing signal. Waveform generators are used in audio equipment and synthesizers to produce different types of sounds. Operational amplifiers can also be used as comparators to compare two different voltages. In this configuration, the amplifier is operated in a saturated state, and the output voltage is either high or low depending on the differential input voltage. Comparators are used in electronic circuits that require a digital output signal based on the comparison of two analog signals. The operational amplifier can also be used as a voltage reference, where the output is set to a fixed voltage regardless of the input signal. Voltage references are used in electronic circuits that require a stable and precise voltage source. In general, operational amplifiers are essential components in modern electronic circuits. Their versatility and ease of use make them indispensable in a wide range of applications, from audio equipment to medical devices to industrial control systems. Thank you for watching. You are free to comment or share this video to your friends. Kindly support us by subscribing and liking this video.